All right, welcome back. This is your 5.6 part 2 for my AP Calculus class. And again, this is Mr. S for AP Calculus. All right, so here we go. This is one of the most typical questions about related rates. So it has something to do with your Pythagorean theorem. So anytime you see right triangle, that is the key. Okay, Pythagorean theorem. Now you can take derivative of each of the sides with respect to t. Okay, notice the letter down here does not match with any one of these characters. So that means when you take derivative, it's the rate of change of each of the sides over time. How fast is side A changing over time? It could be growing like a half an inch per minute, 5 inches per minute, right? The B can do the same thing. Now, if the B is changing, the C is going to change ultimately because it has to maintain that right triangle. The corner has to be closed, okay? And if your A is growing, the C is also growing. Now, if both the A and B is growing, then the C obviously must be growing as well. So that's why all of these will have dA dt, dB dt, and dC dt at the back after you take derivative. Okay, and again, that is your partial differentiation. All right, let's go through this. You can pause and do this before I do it. So this is just derivative, so pause. All right, welcome back after your pausing. So now you got your 2a dA dt plus your 2b, and there's dB dt attached to that, and a 2c, and you got dC dt attached to it. So that's basically the really easy steps. So what does that mean? Well, if I want to find out what is going on about the rate of change of all the sides, you're gonna need to know something about the problems. So let's say if your A is fixed, it didn't change, your B is growing. Let's say it's growing by the rate of 2 minutes per second. How fast is the C growing? So you can probably solve for dC dt. If this is fixed, the rate of change on dA dt should be 0 because it's not growing. They have to tell you how much or how fast is the change of the side B, and we just mentioned it as 2 inches per minute. So you can figure that out, okay? And all these little A, B, and C that has no ratio on it, it's the length at the beginning of the problem, okay? We're gonna do one example now. So there's your typical 3, 4, 5 right triangle. You should know all that already. So now we had done the derivative, so let me rewrite that. So 2a dA dt plus your 2b dB dt equals 2c dC dt. All right, so let's restate the questions. Let's say A is this guy. A is your 3. So we said A is fixed, not changing. And we said the B is growing. I'm just gonna put the arrow at, so that's gonna get taller, at 2 inches per minute, okay? So you got all that set up. You took your derivative from the Pythagorean theorem. So let's apply all these numbers. So this is your B, and the C is your 5. So now you're gonna get your 2 times your A is 3. Now look at what happened here. If they said A is fixed, your A is not changing over time. So it means you got a 0 for the dA dt. So that's gonna multiply out to be 0. So now you got your 2 times your B. The B at the start of this problem was 4. It's still a 4 because that's the triangle that you had. It could be a different size of triangle, so your B will be different. And just based on what the question was. Now we said the rate of change of the B is growing at 2 minutes or 2 inches per minute, so that should be 2 inches per minute. All right. You don't need the units there, it's just too confusing, so I'm gonna erase that. Okay, so now you're gonna get your 2 times your C is 6. And then we can say, well, the only thing we need to know now is how fast or the C is changing. So your C, the length C here has to get longer and keep up with how fast this one is growing. Okay, that's how that is. Imagine if you pull that tip right there up, this will keep stretching while that length B is stretching. So this is 0. 2 times 4 is 8. 8 times, why did I put 6 there? Always my mistake in class. There's a 5. I'm not gonna redo the video here. So 2 times 4 is 8. 8 times 2 is 16. Your C is 5, so 2 times 5 is 10. Then you get your dc dt. So to solve for dc dt, just simply divide by 10 there. So you got 1.6. 1.6 is the change of the length C over time. Okay, so that means you got inches per minute. That's what that is. So we solved that problem. They could have given you, if this is growing, how fast is that growing? Or they could have said this one is fixed, this one is getting longer, how fast is that? Or they can give you not a fixed A. They can say A is changing, say 5 inches per minute. So this one is growing faster, that one's growing at 2 minutes per inches. So you know how to apply all these other numbers. So this one is growing as well as this one. The A and the B are growing. So the C is gonna grow at a faster rate, assuming. Okay, so that's that question, we're done. The next question, I'm gonna use the same triangle, but I'm gonna show you how to apply apply the related rates to solve different kind of problem with the same triangle. Let's say the area comes up. So here's a triangle that we had. Okay, so let me delete all this here. I was doing a problem on this one earlier and I ran out of memories. So that's why I had to redo it. I'm not redoing it again. I deleted some files on my phone, so now I have more memory. Hopefully I can make up for that. All right, so area triangle. You got A, which is the area. That's gonna be a half. Base times height, right? Now, since we call this the A, your A is your base. We call this the B is the height. So we're gonna exchange that out a little bit and make it look according to what I had on ABC or triangle. So this is this length. So now, this H is your B. Okay, so just don't get confused there. Just pause and think for a little bit. You don't want the variables to be other than what you have. All right, so the question is, how fast is the area growing? That's why I needed the area the triangle formula. So that's a question mark, not 7. If A is fixed and B is growing at a rate of 2 inches per minute, okay? So let's see. They said how fast is the area growing? So they're looking for dA dt. So we're gonna take derivative of that area with respect to time. So you are looking for dA dt. Now they said A is fixed. Fixed means it's constant. So you don't have to take derivative of this one. There's no product rule involved here. Okay. So now when you take derivative of this one, it should be 1 dB dt. So you got A over 2 You got a 1, we don't have to write the 1 because derivative of that b is just 1 exponent, right? Your exponent is 1. But then you got your dB dt sitting here. So there goes your formula after you take derivative. So this equation right here is going to tell you how fast the area over time is changing over time with all of these known factors. You should know what they are. The length of A at this moment is 3. So you plug in a 3 here, over 2. Now the rate of change of your B is growing at 2 inches per minute. So this is 2 inches per minute. So now your 2's cancel, right? This is going to be your rate of change of the area. Area is changing by 3 square inch per minute. Hope that's right. Okay, it's the area that's changing at that rate. Okay, I'll see you on the next video.